Hello, everyone. I am Olivia.
I'm Angela.
And I'm Sean. We'll be presenting to you our project on world happiness.
So here is a diagram indicating the steps that we took to carry out our project. First, we researched and picked a specific dataset called World Happiness Report from the Kaggle website, which includes data on the happiness scores composition through the years 2015 to 2019. We then normalized the data since the different columns varied on a wide range before normalization. Finally, we assigned the labels and features and divided the data into training and test sets.
After obtaining the data, we started the coding part of the project. We chose to build two different types of models for each year between 2015 to 2019. The first type of model is the basic linear regression model, and the second type is the neural network model. Then, to evaluate our models, we calculated the mean absolute error so that we can clearly see which type of model is more accurate.
Finally, we ran the code and tested our models. The final performances of our models are mostly accurate since the mean absolute errors are all below 1%.
So here is the visualization of the linear regression model from the year 2015. It includes a pair plot of several different variables, such as the happiness rank, happiness score, economy, which is also GDP per capita, family, and also health.
Next to it, there's a graph of the loss function, which shows how accurate our model is. As you can see, the error decreases from 5 to less than 1.
Below the loss function is the model for the relationship between the happiness score and health, which is life expectancy. Most of the data points in the graph follow a positive linear trend, but there are a few outliers.
Here are two graphs from the neural network model of the year 2015.
The graph on the left shows that as the epoch increases and the model gets more training, the error decreases before converging.
On the right is a scatter plot of the actual data points and the prediction line generated from our neural network model.
And here's the data visualization for the year 2016 of the linear regression model. So on the left, we have again a pair plot of several different variables that shows their basic relationship. And then here again, we have the loss function, which shows that the error decreases as the epoch increases. And finally, we have a scatter plot of the actual data points with our prediction line generated by the model.
Here are the two graphs for the 2016 neural network model. The graph on the left shows that the error decreases as the epoch increases. And on the right is a scatter plot of the data points and prediction line generated from our neural network model.
This is the linear regression rate for 2017. Again, the error decreases with more training, and similarly, the score increased as healthcare improved with fewer outliers.
And here we have the graphs for the neural network model of 2017. Again, we have on the left a graph of the loss function, showing that the error decreases as the model gets more and more training. And on the right is a scatter plot with our prediction line, showing that as health or life expectancy increases, the happiness increases too.
Here we have the 2018 linear regression model, and similar to the previous years, there's a pair plot on the left illustrating a few variables, and on the right, there's a graph of the loss function showing the error decreasing, and below, there is a scatter plot showing the data and prediction line.
And this is the neural network model for 2018. It followed past trends, and as epoch increases, MA decreases, and as life expectancy increases, happiness scores increase as well.
And here's the data visualization of the linear regression model from year 2019. So on the left, we have again the pair plot demonstrating some basic relationships. And then on the left, the loss function shows that the error again decreases as the epoch increases, since the model is trained more and more. And finally, we have a scatter plot of the data points with our prediction line.
And lastly, we have the neural network model for the year 2019 with showing the error decreasing and the scatter plot showing the data points and prediction line generated.
So this animation displayed the trend of health life expectancy in different regions from 2015 to 2019. As seen, the healthy life expectancy gradually decreased from 2015 to 2017 until it steadily rose again in 2018. Moreover, the countries in Western Europe tend to have better healthcare, and partially due to that, they have higher happiness.
However, sub-Saharan Africa has a lower life expectancy and therefore a lower happiness score. There are also few outliers from the trend. For instance, Mauritius in sub-Saharan Africa has much better healthcare compared with the other countries in the region.
Also, Singapore, a southeastern country, provided better healthcare in its region, though it didn't have such high happiness, which could be explained as its other factors such as social support or trust might be low.
So in this project, we used a linear regression model and a neural network model for each year between 2015 to 2019. So first, here is the basic formula for the linear regression model. As mentioned before, we aim to compare the relationship between happiness and health. So these were the two variables.
More specifically, the happiness score is the dependent variable which changes according to the health, the independent variable. As for the code, most of it was from the template that the professor provided with the variables changed.
Next, here is the basic form of our neural network models. We build the neural network models with a simple single input, which is the data about each country's health. Then we have three hidden dense layers with different widths of 128, 64, and 33 respectively. Finally, there is the single output layer, which gives us the prediction result.
And here is a summary table of the overall performance of each of our models. You can see that we have calculated the mean absolute error in each case.
It can also be observed that for each year, the neural network model is always more accurate than the basic linear regression model, since it has a lower absolute error.
In conclusion, the best model is the neural network model for the year 2019. In our experiment, it had a mean absolute error of approximately 0.4829%, which is about 0.0613% lower than the mean absolute error of the 2019 linear regression model.
From our experiment, we learned many things. First of all, as seen in the previous slide, in all cases, the neural network models had a lower mean absolute error than the linear regression models. So they were more accurate in depicting the relationship between happiness score and health, more specifically, the life expectancy.
From the animation we created, we saw that a greater life expectancy results in a higher happiness score among all countries in the world. The animation also showed us which countries have a higher happiness score, which includes Western European countries and North America.
Knowing this can be quite helpful in many situations, such as when deciding which country to immigrate or to move to. Lastly, the linear regression models showed us that the relationship between health and happiness followed a positive linear graph from the years 2015 to 2019, which leads us to predict that this positive trend will continue in the future years.
Thank you.
Thank you.